bool is like a bool in every other language. Unfortunately, it is not true and false. It is yes and no. So you're going to be seeing a lot of capital yeses and capital nos in your programs. I think the reason for that is once we start seeing functions, the way the functions are worded, it's kind of like, and do you want this? Yes. And do you want this? No. ID. So if you're more familiar with C and you know what void star is, ID is sort of like that, but for objects. ID just sort of represents like a generic object. You don't know what the type of the object is, but you know that this thing is an object. And nil is sort of the counterpart of null. So nil represents a non-existent object, but it has some special properties. Questions? Okay, so here are some data types that if you saw when we hash imported foundation/foundation.h, which pretty much everything you're going to be doing is going to do. We also get some of these data types, NS_integer, NS_point, NS_rect. These are not objects, and this can be somewhat confusing because it can be somewhat difficult to differentiate between objects and just these type-def things. So they exist for various like legacy reasons, and so like NS_integer exists as sort of this weird bridge between 32-bit and 64-bit, and pretty much use it whenever, like when you're looking at documentation and you see that this function returns an NS_integer, use an NS_integer variable. So none of these are object types. But now just a quick discussion about what classes and objects are in case you don't have any object-oriented experience. So we're going to be defining classes today, and a class it's going to be similar in Objective-C to other languages you've seen. A class is going to define methods and variables, and it's pretty much a blueprint that then objects you're going to create from those classes. So class is going to say like any object of this class should have these variables and these methods. And then it's on those objects that, or in those objects, you're actually going to have those variables. So you have a single class, and many, many objects can come from that single class. It's also important to remember that in object-oriented programming, classes, you're going to have this hierarchical relationship that we're going to be seeing. So like if I define, well, in Java, you might have seen like the object class. In Objective-C, the equivalent is NSObject. So everything, almost everything, in some way inherits from this NSObject class. And so if I define some class person that inherits from NSObject, then I might define another class, student, that inherits from person, and then I might define some other class, 8th grader, that inherits from student. So remember that these classes have these hierarchical relationships, and this is important when you're looking through the documentation, because if I look at some random, like if I look at the Apple documentation for the 8th grader class, and it shows me like the method spelling homework, you might think that's the only method it has, but it has a lot more methods than that because it also inherits all of the methods from all of its parent classes. So you need to look through the hierarchy to know all the methods everything has. Questions? Okay, so .h files. Unfortunately, the interface keyword is somewhat different from what you might think of as like a Java interface and some other languages' interfaces. It's still similar in that you're going to be defining, like, you're just going to list the prototypes of the methods that you want to be in this class. But we'll see later this thing, protocols, and those are going to be more like the interfaces you're used to in other languages. So in .h files, we have this @interface, and so as usual, telling us it's Objective-C. So @interface, and this class is going to be called foo, and then this colon indicates the class that we are inheriting from. So our parent is going to be NSObject. And then this ugly syntax where we put curly braces and then instance variables go in the curly braces. And then underneath the curly braces, we declare all the methods that this class needs to define. And we'll see plenty of examples of those. And then getting into .m files. So pretty much every .m file is going to have its corresponding .h file. Inside of the .m file, we give the implementation of these things. And so here we're going to give the implementation of foo and actually define all the methods that in this .h file we said we would define. Okay, so we'll look at an example. And this time we'll do it in Xcode. Actually, all right. So here we see on this left side we have all our files. I'm going to get rid of this right side because we don't need it now. Up in the down at the bottom, we're going to have our nslog stuff down here. So looking through these files, I'm not going to be able to do that. So looking through these files, we see we have a main function. We have this same auto release pool thing that you can ignore for now. And then we're going to have this student star Alice. So student, we see over here, is going to be an object. We have a .h file and a .m file for it. We'll look at those in a second. Student star, so I guess I'll go into that. Ignore this for a second. So just student star Alice, we're going to allocate the student. So this is sort of like malloc. So we're making room for this student. And then apparently we have some age field and some name field. Let's actually look at it. So here's student.h. And we have interface student. It's inheriting from NSObject. And here we see this @public keyword. This tells us that everything underneath, all the variables underneath this word are going to be public instance variables. There's also @protected and @private. So private, no other class is going to be able to see these variables. And protected, any class that is a subclass of this class is going to be able to access these variables. So you won't need to deal with those too much. Generally, you want to make the access to these variables as tight as possible. So like if the variables can be private, make them private. So here, the instance variables we have are age and name, which is an NS string star. And we see since there are no methods defined down here, that means that, well, let's look at it. Student.m doesn't need to define any methods. Yes? Why did we use what?
Because we use NS as string. Why we don't just use string here?
Oh, so we could use string or just char star, like a regular C type string. But in Objective-C, you're going to be passing around these NS strings a lot. So you're probably going to want this thing to be an NS string. Like when we want to actually print this, we're going to need to print an NS string. We can't, or when we want to NS log something, we need to NS log objects. So we're going to need to pass it an NS string. We can't pass it a char star. We would have to change that char star to an NS string.
But we also have NS integer, right?
Yeah, so NS integer is, this is where it's, NS integer is pretty much going to be just a typedef for regular int or possibly long. This is not an object type. This is not a class. This is just like typedef NS integer int. So this is why like these aren't that helpful unless you see that a function in the documentation is returning an NS integer, and then you should use NS integers.
So these NS something objects, they can be primitive values and object values.
Yes, so that's the unfortunate thing. You get pretty, like, the primitive ones are this NS, well, actually, no, I can't even say that. There are some complicated ones that are primitive, and I wish they had done something to differentiate better, but they didn't. and let's change this back to int, but it shouldn't change anything. So in main, so we are now accessing this. So student star Alice is an object. That object has an age field and a name field, and we are accessing those and setting the age field to 20, and we're setting the name field to be this NS string Alice. Note that this would not succeed without the @ because now it's not an NS string and it yells at us appropriately. And